All right, here's the example that you were looking to try if you were following through on the website. Um, we've got some numbers that are decreasing, so I know it's a decreasing pattern, and I believe if we look at this, we'll see that they're decreasing by the same amount every time, so it's a linear decreasing pattern. If we want to give the rule in words, we're going to start at 193. It's the first number of the pattern. And then we are subtracting or decreasing by 5 each time. Some important information right there. Start at 193, subtract 5 each time. So the first thing we're doing again is finding the 10th term value. And like before, we are going to make a t-chart. I'm going to just give myself some more room here. So 193, 188, 183, 178. There are the numbers that we've been given. Easy enough for me to just keep going. And since I'm going down by 5, it's pretty easy. Every other number ends in a 3 or an 8. Every other number, it looks like, goes down by 10 anyways, because, of course, we're going down by 5, so 2 5s is 10, makes sense. So 173, 168, 163, 158, 153, 148. There we go. So the 10th term value, 148. So again, since we're being asked to find the 21st number of the pattern or the 65th term number of the pattern or term value of the pattern, I'm not going to bother extending my chart. I'm going to come up with my expression. And what I remember is I always check and see how much the pattern's changing by. If it's changing by the same amount each time, which this one is, we can make an expression fairly easily. What I remember from the example from before is that if it's a decreasing pattern, I'm subtracting by the same amount each time. My expression is going to have some number take away, in this case, 5n. The 5 comes from the fact that we are subtracting 5 each time. So I just have to go through and figure out what this initial value is here that I'm going to start taking away multiples of 5 from. And the trick to doing that, let's check our first term value. I know the first term value is 193. So this is going to be where I figure out what number belongs here. I'm not going to put 193 here because this would make it off by 5. I want to know what initial value here. So if I backed up one more spot into the pattern, what number would belong here? So some number, take away 5 times 1 because I'm checking the first number of the pattern. What number, subtract 5, gives me this first term number or term value of 193? What number is this? Well, this number has to be 5 more than 193, so it has to be 198. So this number, 198, belongs here in my expression. 198, take away 5 times the number, 5n. And again, it makes sense that if I backed up one more spot in my pattern, and there were no term numbers, there was 0 for the n here, it makes sense that 198 would be here because I'm going down by 5s. So that's how I come up with the number here in my expression, 198, take away 5n. So now, let's check the second number of the pattern. And let's use my full expression now. 198, take away 5 times 2, because I'm checking the second number of the pattern. 198, take away 5 times 2 is 10. Well, that's 188. 188 is indeed the second number of the pattern. Looks good. Try one more. If I can do the first three, I'm always good. 198, take away 5 times 3. Well, 5 times 3 is just 15. 198, take away 15 is 183. Perfect. The third number of the pattern is indeed 183. Now I'm confident, and now I know for sure my expression is correct. So to calculate any term value that I want, I'm going to use this expression. 198 take away 5 times n, the term number. Sweet. So the problem asks us to figure out the 21st term value. Okay, we'll use my expression and pop in 21 for the n. 198 take away 5 times 21. Well, let's do the multiplication first. 5 times 20, that's easy, that's 100. One more 5 would be 105. 198 take away 105 is 93. So if I kept going, the 21st number of the pattern is 93. Makes sense. The odd number term numbers are the ones that ends in 3. So that makes sense to me. Good way for me to check that I've done a good job calculating here. So the 21st term value is 93. And then the last one that wants us to check is, what is the 65th term value? Well, I'm going to use my expression again. 198, take away 5 times 65. Five times 60, that's 300. 5 times 5 is 25, so I must be 5 times 65 must be 325. So again, here we are in a case where I know I've gotten far enough into my pattern that the numbers are going to be negative. Because I have 198 to start with, that's my initial value that I have in my expression. And I'm taking away more than that. I'm taking away 325. So I want to be careful that I don't make the mistake and think that this is going to be a positive number, because it's clearly going to be negative. I'm taking away more than I have. 198 take away 325 gives me negative 127. So the interesting fact here is that the 65th number of the pattern, if I kept going, is negative 117. What's weird about that is now all of a sudden the number ends in a 7, where they've been 3s and 8s up until now. What I want to do is figure out, does that make sense? Because somehow something's changed. What I want to see is, if I kept going, when would I get right around 0? So I can see what happens right around 0. So what number for n here would give me about 0 for my term value? Well, let's see. I'm taking the term number and multiplying it by 5. So I want this 5 times a number to be close to 198. So I know that all multiples of 5 end in a 5 or a 0, so let me see if I get closest to 198. That would be a multiple of 5. The closest number to 198, without going over, that's a multiple of 5 is 195. If I divide that by 5, that gives me 39. So what that means is, in here, the 39th number of this pattern is going to be close to 0. Okay, well, 198, take away 5 times 39. Well, 5 times 39 is 195. 198, take away 195 is 3. There you go. So the 39th number of the pattern, so if I tuck it in here between the 21st and the 65th, the 39th number is a 3. And I'm going down by 5 each time. So the next one, the 40th number. If I continue this pattern and I go down by 5 again, well, if I go down 3, I'm at 0. So I go down 2 more, I'm at -2. The 41st number of the pattern, -7. So now what you're going to see is because of how it changed right around 0, once the numbers are into the negatives, they're into a 2 or a 7. So, yeah, okay, this does make sense. The math works out. I didn't ask you to figure out any of this, but if you wanted to do a little sanity check and see, well, why all of a sudden does the number end in a 7? It's because of what happens when you go from the positives to the negatives. Cool. So this was just a little mental check for me to do. But the 21st number of the pattern was 93. The 65th number of the pattern is -127. Whoops. What you notice here is I wrote the wrong number down here. Let me just double check that. Yeah, it should be 127. Let me fix that. There we go. Good job. Got to double check your work. Got to be careful that you don't make silly mistakes like I did and almost missed it. Okay? Awesome.